This is a Razor 2020 DXT drift trike. Now, I'm pretty sure this would be fun as is, but if growing up on the internet's taught me one thing, it's that putting motors on it would make it a lot more fun. But it's 2024. We can't be taking any motor and strapping it to this. No, we're gonna go electric. And trust me, with electric, there's a lot more possibility to go crazy. So we're gonna be taking this ordinary drift trike and changing it into this crazy off-road electric vehicle with some other cool features. So strap in with the non-existent seatbelts and enjoy the ride. Man, this would be so much easier with motors.
Well, speaking of motors, that's where this project started. About a year ago, someone posted a link to Discord, a link to some replacement hoverboard motors being sold for $10 each. This link spread like wildfire. I thought it was a misprice and the order would just get canceled, but a week later, a torn up box arrived at my doorstep with motors inside. I sat on these motors for over a year. Life was busy, nothing was coming to mind that hadn't been done already, but I was yearning for a project to use them on. And then...
Hey man, what's up?
Not much, you?
Oh, me? Nothing? Wow, what's good with you?
I'm going to this nerdy camping thing. You want to come? I got space in the car.
Yeah, I'd be about some nerdy camping thing. Is it cool if I make a project?
Just gonna take up all my trunk space. Is that cool?
Yeah, sure thing.
So now I had a project. I paused for a second. And then I went back to thinking. What's the one thing that is the embodiment of camping? The cooler. It keeps your food edible, your drinks cold. It's a thing that people talk around. It's a seat, it's a table. It's just not camping without one. Well, now that we have some direction to go off of, it's time to play...
Who's that?
Donor Vehicle!
It's
Razor 2020 drift trike.
I went with the drift trike for three main reasons. First, it has a steering wheel already on it, which would be hard to make myself. It also has a mechanical brake up front, which gives me some peace of mind in case of the regen braking on the hoverboard wheels just suddenly cuts out. Last, it has a nice wide platform between the two back tires, so it'll fit the cooler nicely. But the trike isn't going to be that great at off-roading. It also only has 2 wheels, and I have 4 hoverboard motors, and 4 is better than 2. So we're going to get rid of the wheels and replace them with some plywood triangles. These triangles can rotate on the existing wheel axis, and then we can put 2 hoverboard motors on the bottom of those, for 4 total. This means more grip, more power, and the wheels can contour to the ground. Great! Next, I made a cardboard cutout with a straight edge and a random cocoa powder cylinder that just happened to be the right shape. And with a bit of YouTube magic, I cut out a piece of wood that was approximately the same shape. After that, I headed over to my buddy's backyard because we're going to be making a lot of sawdust. After transferring my template to a sheet of plywood, it was time to get cutting. After a bunch more of that, I had all my blanks, and we could start routing them. I also forgot to show it, but I made a little base for the cooler. It's just some 2x4s and some ply. You can figure it out. I'm using some X-Fasten woodworking double-sided tape to hold the template onto the blank. It worked pretty well. I had one bad peel.
I leave this in just to annoy like the one OCD person.
Besides that, it came off pretty easy, and it held the wood decent enough. After that, we broke out probably the most scary tool that we have, which is the router table, just to trim up the blanks to be the same size and shape. It went pretty well, but I had one almost accident. And that's why you keep your hand in the area where the blade wouldn't pull it into the blade if it grabs. Yeah, safety. When I got home, I realized that the thickness of the wood was a little bit off, so I had to make some spacers. Instead of going back to my friends, I just used my CNC to make them. I'll do a video on it someday, but this isn't a CNC channel. I could have done it with a 3D printed template and the router table, but I was kind of running out of time for the project, and this is what I had on hand. Now with those spacers made, it's just on to assembly. So enjoy the sounds of the workshop, and I'll be back when there's gaps that need some explaining. So our little triangle pieces are made out of 3 sheets of plywood stacked up, and then there's this little metal thing that came on the drift trike, just on the axle. Probably didn't need it, all the weight's going to be on those bearings anyway, but stuck it in there for good measure, and then we just glue on the spacers. The hoverboard wheels are interesting. The shaft stays still, and the motor is actually inside of the wheel. There's a flat spot in the shaft, so I'm making this aluminum plate that the flat spot will mount up to. You'll see how it mounts in a bit. Okay, so here's how the motor mounts. The U-bolt goes in, and then it pulls the motor shaft into the aluminum bar, and then it gets tightened from inside the cutout in the triangles. With the wheel assembly done, it's time to move on to the beast of a battery that's going to power this thing. It's all custom built, the frame of it is 3D printed. The battery is a 14S5P configuration. In simple terms, that means it can deliver 125 amps at about 50 volts. 58 if it's fully charged. That's a lot of power. Should get us moving pretty fast.
I realized during editing that these numbers probably don't mean much to people. So let's compare an 18650, what this battery is made with a battery that you would find in a TV remote, a AAA nickel metal hydride. So batteries like this have spec sheets online, which makes it easy to look up. But these guys, they don't. So we're going to do a little test to see what kind of power this battery can deliver, so we can compare it to this one right here. I got my multimeter set up to read the amperage coming from one of these batteries. We also need to see the voltage, because as you pull power, the voltage of the battery starts to decrease. I kept adding more resistors into a resistor network to lower the resistance, and that way we could dial in right when the current draw from this battery starts to cause the voltage to drop. We can see that we get right about 1 amp pulled from the battery. I didn't have a good way to measure the amperage and voltage at the same time on my multimeter, so I'm using my oscilloscope to see the voltage. So if you look at this number right here, first up reading the voltage directly from the battery, you can see we have 1.36 volts. Next, let's hook that resistor network back up, and that way we can see what the voltage drops to while we're pulling power. We can see that our voltage goes down to 1.2 volts. So using that, let's start comparing these batteries.
As mentioned earlier, our big battery is able to deliver 125 amps. Since our small batteries are each able to deliver 1 amp, that means we need 125 of them in parallel to deliver the same amount of amperage. Next up, we need to consider voltage. Our big battery is able to deliver 58.8 volts fully charged. These batteries can deliver 1.2 volts. That means it will need 49 batteries in series to get the correct voltage. That means we need 6,125 AAA batteries in order to deliver equivalent power to what my battery can. Laying all of those batteries end to end, we would have 257.25 meters of batteries. Or if you're in the US, that's 1.27 furlongs, or 2.81 football fields in length. And for your European people, that's 0.85 Eiffel Towers in height. We also know the joules of energy that are in the battery, 2,289.6 kilojoules to be exact. We can then calculate how many pounds of TNT that is, which is 1.1 pounds. Now, I wasn't able to find a 1 pound TNT explosion on YouTube, but I was able to find a 1.5 pound TNT explosion, which is pretty close. So yeah, there's a lot of energy in this battery. Granted, The TNT is releasing it all at once, and this battery would never be able to do that, but it goes to show you, we got a lot of energy to work with. I would say the bulk of the time for this project actually was making this battery. I didn't count, but there's definitely over 200 nickel strips that all had to be spot welded multiple times, and then making all of these really thick wires to carry the massive amounts of power this thing can deliver. When you're dealing with this much power, you pretty much have to use hydraulic crimpers. If you try to solder, it does work, but those copper wires soak up so much heat, you spend 30 minutes just trying to solder one wire. No joke. Skipping past all the boring stuff, I got all the wires soldered, I got the magic space tape on, so it's time to check that it all works. I've already tested it with a multimeter, but this is a full test with all the different components that will be on it when it's inside of the battery tin. Oh yeah, the battery tin. So because the battery is just 3D printed, I worried about the durability of it, especially since it was going to be on the outside of this cart. What if it flips? What if it hits a tree? I want something a bit stronger than plastic. So I got a steel ammo tin. It was a bitch to work with. There was cutting oil everywhere, it was super loud, especially in an apartment. I kind of wish I went with a plastic one, but hey, steel is stronger than plastic, right? I cut all the different cutouts, I snapped in all the little bits, and the only thing left was to heat shrink the battery and put it in the tin. I hated the steel tin while I was working on it, but let me tell you, when this lid closed, everything fit so perfect with just a little bit of foam on top, kind of made it worth it.
Alright, so where are we? We have a battery that works, and the wheel assembly is mostly done. The next thing is control electronics and wiring. This is where the project really started to crash and burn. Emphasis on the burn part. I got these $20 speed controllers on Amazon. Turns out they were only $3 in AliExpress, which kind of speaks to the quality of them. Now, I'm a bit at fault since they were rated at 350 watts, but I was pumping nearly 1,000 watts through them. Yeah. I'm a fan of showing failures. It's an inevitable part of making, and it's not often shown because it's a little embarrassing, and it takes up time in the video. But I want my videos to inspire people to make things, and I don't want to give a wrong impression of the hobby. That being said, besides seeing your project come together and work, the most rewarding part of making something is encountering problems and then solving them. So let's dive into what went wrong, how I fixed it, and how to avoid the same mistakes. Normally, I shoot at the end when things work, but I like to take photos and videos along the way to share on Discord, so let's bust out the phone. I got a cheap e-bike throttle on Amazon. It works like a variable resistor. Voltage goes in, and depending on how far down the throttle is pressed, a higher or lower voltage comes out. Sweet. Now that that's tested, we can go ahead and throw it on the cart. Next up was seeing what kind of speed we were going to get. I did a quick full throttle test with a handheld tachometer, and oh boy, I did not expect to see the rubber wheel expanding on the rim like that. Yeah, it could have been pretty bad having my hand that close, but ignoring the dangers my fingers were in, and let's do the math, it turns out to be 65.8 miles per hour. At that point, I added a dead man switch from the main electrical connection to the battery for safety reasons. The way it works is pretty simple. This is the main positive run that would be coming out of the battery. I have this bit right here that just pulls out and cuts the connection. Now, on the cart, this right here is attached with a long chain of zip ties that clips to my belt, and that way if I fall off, power gets disconnected. I played with the throttle a little bit more off camera, and I started burning out the speed controllers. I thought I would solve this in software by implementing a PID loop. PID loops are all around you, from the hot end in your 3D printer to the thermostat on your wall, assuming it's a newer thermostat. They're a great way of controlling some output to reach a desired state. For instance, on these cheap speed controllers, they take in a PWM square wave to command a certain amount of power going to the motor. They also output a pulse as the motor rotates. The quicker the motor rotates, the faster that pulse comes. If we know the desired speed of our motor, we can look at the pulses and send more or less speed signal depending on how far away we are from the desired state. The PID control gives us variables that we can tune to kind of get like a desired snappiness, as well as removing some oscillations. I thought this could help because we could purposefully make it not snappy, gradually increasing the power going to the wheel instead of just jamming all the angry electrons through the speed controller all at once. Turns out, it didn't work, and I was traveling to OpenSauce the next day. OpenSauce was tons of fun, and I highly recommend it if you can make it. While I was there, I got to pick the brains of some other makers to see if there was a solution to make these cheap speed controllers work. A fellow maker recommended that I add some resistors in series with the DC side of the speed controller, essentially limiting the current that the speed controllers could pull.
With those and some more cheap speed controllers ordered, I enjoyed the rest of the event and forgot about the build until I got back. Well, turns out the resistors worked. Kinda. At least on the test stand with the motors in the air, nothing was breaking anymore. I had a week to go until the project was going to be done, so I took the time to make a bunch of custom wires, add a goofy horn, and make a new label for the battery, replacing the info about the ammo that would normally be inside with the info about the battery pack. I think it turned out pretty good. It was also the first time I used a vinyl cutter, and I did some things wrong. I did a white background and then cut out the individual black letters, and that was a whole mess. I really should have done a black background and then put a white mask in front of it. I also did some other stuff like making this dumb flag, just side quests like that. And then only after I got through all of them did I decide to go outside and give the kart a test drive. It went well. I drove around for 10 or 15 minutes, and then I finally called my girlfriend down to come and film. As soon as she started rolling, disaster hit. I lost power on the right side of the cart, and after pulling the cart back up onto the sidewalk, I could see smoke pouring out of the electronics. 1.5 days before this was going to be loaded in a car and taken to an island 4 hours from all my tools. Shit. Also, quick note, these speed controllers, they're like actually dangerous. When they fry, they short out on the DC side, like 0 ohms. So if you had a LiPo battery connected to one of these without a fuse, your battery would literally explode. So yeah, use these with extreme caution and probably avoid them unless you know what you're doing. Yeah, I got back upstairs and started inspecting the damage. I was feeling pretty defeated. I started disconnecting everything, knowing I had a late night of rewiring ahead of me. Thankfully, while at OpenSauce, I also ordered some much more expensive backup speed controllers. The problem though is they used a completely different control signal and they didn't output a speed pulse, meaning I had to scrap all the custom ESP32 control stuff that I did, as well as the PID loop, and pretty much all the existing wiring too. So, to keep it short, I wired the throttle directly into one of the speed controllers, and then I used that one as a master throttle on the CAN bus that was connecting to all the other 3 speed controllers. So that let all the speed controllers talk together and share the throttle signal. These new speed controllers are based around vesc, which is super customizable. It's really cool, unless you only have a handful of hours left to work on a project, and then it's less cool.
All right, it's almost midnight. Got the speed controllers all going, got the new throttle control, got the VSC stuff set up. Yeah, it's working. Hooray.
But the rewiring was complete, and I could do any final tuning on my laptop once I got to the nerdy camping event. Alright, we made it. We got the cart in the car, it was loaded to the brim. Literally stuff strapped to the roof of the car to make the project fit. We got everything unloaded and our camp spot set up. I spent the first night cooking and getting the cart working, but it worked! Let's go! After that, it was a lot of driving the cart around and seeing all the other cool stuff that people had made and brought with them. It was a great conversation starter. Since people wanted to come up and ask about it, I could just turn the tables and ask them about their own contraptions. But you're not here for that. You're here for the cooler cart. So let's take it for a spin. So it started to get a little rainy. Classic Pacific Northwest problem. With the help of a tarp, it still made a great table to set my beer on though. Thankfully, I waterproofed the electronics well enough that even with the rain, I could still putt around some. So let's take it for another spin. The fastest I got going was down a gravel road a bit away from the event. I didn't want anyone nearby, and I didn't film it since I wanted all of my attention on the vehicle and how it was behaving. I would say it got up to about 35-40 miles an hour. It definitely could have gone faster, but that was plenty enough for me. I thought this would just be a goofy show and tell project, but it turns out it was actually useful. The camping event was 5 days long, so we needed more ice about halfway through. The general store was about a 10-15 minute walk away, but I was able to drive right up to it, load the ice into the cooler, and drive right back. Besides that though, it was a great way to meet so many cool people. And I gotta say, it was a pretty fun way of getting around.
Howdy. If you came to the event, thank you so much for making the event what it was. It was my first year going and I had a blast, and I can't wait to see you all in a few years. Now that the event's over and I'm back home, what became of the project? Well, it was driven pretty hard. Sadly, the axles on the kart bent out enough that it no longer fits through doorways with the wooden things and the hoverboard wheels. So I took all the electronics off for the next crazy project. I composted the wood and I donated the drift trike to a local thrift shop where all the proceeds go to help support people in the LGBT community. Hopefully some little kid gets some fun out of it and then passes it along to someone else after they grow out of it. On to the lessons learned. Prototype, integrate, test, and then refine. I messed up and I prototyped the motors on my workbench, then integrated them into the project, but I jumped straight to refining the build before testing it outside. Get the main project done before moving on to side projects. No one at the event noticed the battery decal. I'm sure no one watching this would have either if I didn't hold it right up to the camera. I'm not saying I didn't like doing it. I love making goofy small touches to projects, and it was my first foray into using a vinyl cutter, so I learned a lot. But would the project have worked without it? Definitely. Would it have killed the project if it took me an extra day to get the vinyl cutter working? Definitely. So save that stuff until the end. Lastly, this is specifically for DIY vehicles. Use disc brakes. I had 30 amps of regen braking split across all the motors, and it worked really well at slowing down the cooler kart. But even with all that regen, I had to adjust the brake pads twice during a 5-day event to account for wear. I hope this encourages you to go out and make something. Nothing in this project used CAD, and all the electronics, the ESP32 code, the GUI code for the PID control loop, all of that was new to me. If you wait to make something until you know how to do it and have the skills required, you'll never learn and you'll never get to your project. So jump in, make something cool, and then share it with the world. Anyway, until next time.